Good morning or good afternoon. When I participated to the workshop in 1989, I was young and enthusiastic. Bionics was a new label that looked like a North Star for cutting-edge research. I contributed also with 2 papers. However, after 32 years, I have some doubts that can be formulated as 2 questions. Maybe yesterday's Bionics implied too many unfulfilled promises? About the Bionics today, is it still a North Star, and is it worth continuing along the same line? More specifically, I have 2 objections, a minor and a major one. The minor objection can be formulated as follows. By looking at the table of contents of the proceedings, to which extent is it correct to label that kind of scientific meeting as bionic and not simply multidisciplinary in the traditional framework? The major one is more general. Is bionic running on the narrow ridge between science and hype, overselling futuristic, fantastic applications that frequently fall short of expectations while resting on shaky scientific basis? Of course, the same major objection can be directed to other catchy labels like artificial intelligence, biorobotics, cyborg, and things like that. Moreover, the history of such catchy label is full of unfulfilled expectations, such as those produced by Marvin Minsky or Herbert Simon. According to Wikipedia, bionics can be defined as the application of biological methods and systems found in nature to the study and design of engineering systems and modern technology. However, this definition misses the bidirectional linkage between biology and engineering, not only from biology to engineering, but also the other way around. In any case, all of this was already present in a seminal definition of cybernetics by Norbert Wiener, sculpted in his book. Let me try to put this story into perspective, although in a very simplified manner. Everything started with cybernetics, of course, then Jack Stiles defined bionics, John McCarthy and colleagues artificial intelligence, then industrial robotics became something actual, cyborgs entered the scene, then social robotics, and finally Industry 4.0. It is also worth pointing to different sources of funding. Defense funding first, then at entertainment industry when Hollywood discovered that cyborgs were sexy, and more recently the social media industry on one side and the advent of Industry 4.0 on the other. Moreover, we should take into account that cybernetics was not only the grandfather of the red label disciplines, but also the set of engineering disciplines that later were grouped collectively under the umbrella term ICT, and that, of course, are a driving tool of Industry 4.0. However, this is not enough. The intelligence robots of Industry 4.0 need a crucial new tool that can be labeled cognitive robotics. As a matter of fact, Industry 4.0, that is also identified as the fourth industrial revolution, is mainly characterized by cyber-physical systems, and in my opinion, such systems should be bio-inspired in order to make possible interaction and cooperative partnership between humans and robots in factories, social conditions, and generally unstructured environments. But what does it mean exactly by inspiration for the cognitive robotics? This is the questions to be addressed in the next decade. In any case, bio-inspired should not be interpreted in the sense of fine-grained imitation of neurobiology, but in a large framework of embodied cognition. Thus, the crucial challenge is not bionics, but bio-inspired cognitive robotics for suitable cognitive architecture. To be honest, cognitive robotics exists since at least 40 years, but mostly in the domain of traditional AI with limited human-robot interaction. In any case, I do not think, as some people suggest, that cognitive robotics can be achieved by joining excellent real-time control with deep learning AI. Consider the Google definition of intelligence. Intelligence is the ability to perform well over a wide range of environment. Smart, but a kind of oxymoron, and in any case, no linkage to neuroscience. Moreover, mainstream AI completely lacks the capability of a first-person experience and the learning that characterizes humans and social interaction, skill learning, skill transfer through episodic memory. Moreover, cognitive robotics required multiple time frameworks, real-time of course for control, but also behind the real-time for memory recall, beyond the real-time for prospection. In any case, bio-inspired cognitive robotics should be fully compatible with the original cybernetic concept of a bidirectional interaction between biology and engineering. Bio-inspired cognitive robotics should focus and contribute to the accumulation of knowledge in motor neuroscience and cognitive neuroscience, with specific reference to motor imagery, embodied cognition, motor simulation theory, prospection, and so on. The working hypothesis is that humans and the cognitive agents will be able to be engaged in cooperative purpose behaviors only if they share such sensory motor cognitive function. The final message is thus that bio-inspired cognitive robotics might be the best perspective of bionics today and tomorrow. Thank you for your attention.